Cool. I hope that some of the other stuff we were jumping through was helpful and a good warm up. And Jay, thank you. We totally should focus on the main event, which is forking. And so gonna roll, click on this install fest file. And scroll down. Let's look at the 99 bottles assignment. So we've got a normal link here. If I look up here, just to illustrate, I can tell that. So what I see in the URL and over here where they sort of show us the path, which is the term that you'll see, we'll talk about URL paths, directory paths, anything where it's kind of like where we're organizing directories or files or things in some sort of tree-like structure. This is our GitHub organization, and then this is our Git repository or our GitHub repository. And can someone real quick maybe give me like the 10,000 foot view explanation of what a Git repository is?
From my understanding, it's a way to kind of keep everything organized from like the main person that created it and people that are editing it with their files. They're able to see it, just more of a public tree through like files and stuff. I don't know if that was the best way to.
Yeah, that's a great explanation. Like Git is a tool that programmers wrote to help them organize their source code files. And source code is just a fancy name for all of these text files that we're writing our code in this specialized language. So this Git repository, at least on this branch that we're on, and we'll talk more about branches later, has these 3 different files. 99_bottles.js, 99_bottles.py, and readme.md. Readme is really common. Let me do the forking and kind of show everyone how to get rolling with this. So on github.com, I want to make sure I'm logged in and ready to go. What forking lets me do is it's going to create a copy of this repository, but not on the Sierra Platoon GitHub organization. It's going to create a copy on my own GitHub user account. So to fork, you just click on fork. Describes it here. It's a copy of a repository. It lets us make changes without changing the original. The owner is the GitHub user where this repository is going to be created. That's me. It's my account. These are the different organizations I belong to. You want to fork to your own user account, and I would just leave the repository name the same. If you want, you can add a description. We haven't talked about branches. It doesn't really matter. For all the homework assignments, this copy the main branch only, at least for the first couple of weeks, should be more than sufficient. So we just go ahead and click this create fork button. And so now I have a copy of that code, of those files, but it lives on my computer, or not on my computer, I'm sorry, on my GitHub account. I can go here, I can edit this README file. I'm going to go ahead and save those changes. And if I go back here, I see that on the Sierra Platoon GitHub organization, those changes don't there because there's 2 totally separate things. So forking is step 1, creating a copy. Everyone feeling good about that process? And are there any questions around it? I know there's a lot about Git and GitHub that is new to people and that we haven't covered yet. And we will. I just want to check in about if people are feeling good about that basic operation of creating your own copy of a repo or of a repository. Cool, awesome. So that's the first thing. The second thing is now this copy is living in the cloud, in some server, in some data center somewhere. I want it on my computer, so I can edit this code in VS Code and I can run it. So the whole idea of Git, this program, this strangely named program, is that you can have multiple Git repositories and you can send information back and forth between them. I have to think about if there's a good metaphor there. But that's what this clone command that we're going to do is. And the word clone should kind of clue you in, because a clone is like an exact copy. There's a couple different ways that you can do this. We'll walk you through SSH authentication on your laptop if you don't have it set up. It's nice. These all do the same thing, but because what's going to happen is when we make a copy of this Git repository on our own computer, we're going to want to send the changes that we make on our computer back up to the Git repository in the cloud on GitHub. And we might want to pull some changes that happen to the one in the cloud back down to our computer. We need a way for those two repositories, the one on my computer and the one in the cloud, to securely talk to each other. And these are different methods of authentication that we will learn more about later. If you can use SSH, use it. If you don't have SSH set up, I would say use HTTPS. It'll prompt you for your GitHub username and password on the command line. So this command here, it just copies this URL, which looks a little different than a normal one. Like if I paste it in here, there's no HTTP or anything like that, because it's not a website. It's a different format without really worrying about it or going too much into it. I'm actually not exactly sure what it is. And we're going to do something with this on the command line. And what we're going to do is I'm going to make my terminal bigger. So first of all, I want to make sure I am where I want to be. A nice trick in VS Code is if you right-click on a directory in the Explorer, there's an option, Open an Integrated Terminal, that will open the terminal to that directory. So if I did that here, open an integrated terminal, I'm now in my code directory. If I do it here, open an integrated terminal, I'm now in my day one directory. I'm just going to get rid of these. It was opening a bunch. So we talk about GitHub and we talk about Git. They are two different things. Git is a program that we can run from the command line on our computer, and that is also run on servers in the cloud. GitHub is a company that provides hosted Git servers as a service and kind of wraps it with this beautiful user interface and all these other things. The tool that we use is called Git, and we use it to manage changes to our source code, the different versions, which is what we're going to see in a second. And on the command line, I can type Git. It prints out a ton of stuff. If I type man Git, it tells me a little bit about this program in the manual. If I type which Git, it tells me where on my computer this program Git lives in the directory /user, USR is short for user, /bin, which is short for binary. Binary as in something, a file in a binary format that the computer can execute. which is why we can type Git stuff on the command line. And the Git command you will use the most is Git Status, which gives you information about the Git repository that you are currently in. And we're not in a Git repository right now, which is fine. We're not supposed to be. And we see that message. I could create a Git repository on my computer very easily if I use the command git init, and I just created a directory called my repo and I navigated inside it. We get all this stuff and it tells me I have initialized an empty Git repository in this directory, my repo. If I type Git status, it gives me some information that we'll learn more about later about how the program Git is tracking the files in here, but there are no files in here right now. If I type this ls command to list all the files, I see nothing. The ls command has a flag, -a. This shows us files or directories that start with a dot. On the command line, files or directories whose names start with a dot are treated special. They don't show up when you normally look at things. You have to use this special command to see them. They're normal files, normal directories. This is just a convention of the terminal and of the shell and of the command line. Without getting into it too much, our Git repository has this directory .git. It has all sorts of stuff in it. Inside here is everything that makes a Git repository a Git repository. All sorts of magic happens inside there that we're not going to worry about for the moment. If I deleted it, that Git repository is gone. This is just a normal directory again. That I know there was a bit of a digression. I wanted to explain a bit about Git and show you a little bit about what it is so that our cloning command isn't totally magic. Before I do the clone to bring our repo onto our computer, let me just check in and see if people have any questions about kind of the stuff that I was just talking through. I know there's a lot of stuff. Again, today is really an overview. Don't worry about like memorizing or mastering all of this. This is more of like an overture. You know, the overture of a movie, you hear like little bits of all the different songs and the themes so that when you hear the theme in the movie, you recognize it. That's kind of what we're doing today. That said, do folks have any questions?
I have one.
Yeah.
And I hope I'm not kind of jumping ahead. I think it's kind of right where we're at. When you have it and you copy the to your files and stuff, and how are we going to send it to you? Are we actually just editing that source code when we upload it, or is it going to be like a totally different thing?
Yeah, that's a great question. Two parts there. One part is that, to be completely honest, we're not able to review the daily homework assignments as thoroughly as we'd like. So we probably will not be able to look at everyone's code every day. The second answer is that what we're going to see in a couple minutes is basically you will send the changes that you made on your computer up to your own GitHub repository, and you can just share the link to that with us. And that's how we can see that code. And I think that's the perfect time to walk through, I think, finally cloning and making changes and pushing changes back up. So just to reiterate, for this clone command, I'm copying this URL. And what I'm going to do is I'm in the directory I want to be in, my code directory, week 1, day 1, or maybe it's code/curriculum week 1, day 1. and I'm going to use this command Git Clone. And as you've noticed on the command line, you can sort of use sub commands. Like Git is a command that runs the Git program. But if you type Git Clone, we are running the Git program and telling it to also run this clone command. And it spits out this big message because we're missing one more piece. And so again, kind of chaining these commands together, we are telling the Git program to run its clone command and clone this repository. And this is a URL. And a URL is pretty much a link. It just doesn't have to start with HTTP. URL stands for Universal Resource Identifier. Like the website links that we see, like HTTP this, or HTTPS, NewYorkTimes.com. That's just one kind of URL, but it's by far the most common on the web. And then GitHub and Git has its own sort of special URL format. And when I type this command, Git is going to talk to my GitHub account, grab that repository, and pull down all the information about it. And now I've got that directory algo99 bottles. And I want to briefly delete it because I want to point out, well, yeah. So the other way to clone it, because my computer has to securely talk to my GitHub account. So I would try SSH first, and if that doesn't work, maybe try HTTPS. And when we do it that way, note that we see a much more normal looking URL. And it's going to, I don't know what it's doing with all that stuff. I guess that worked as well. Actually, it will make stuff a little different when I move information back and forth, but I've still got my 99 bottles directory right here with my files. I do want to actually SSH into that, but I wanted to demonstrate those two approaches. So if you haven't, I would say give this a shot right now, Git clone and the link to your repo that you want to clone, and see if that works for you. And while we're doing that, and now I've got this directory.
Adam, can I ask you a question about this before you go much further?
Yeah,
we
absolutely.
just retrieved the code for 99 bottles into the day one project or the day one folder. What if we want to retrieve a second project into that? Shouldn't we have created a 99 bottles folder under day one?
Great question. So the Git clone command also creates a new directory that has the same name as the repo. And so there is a completely normal folder or directory named algo99 bottles right now. And let me go ahead and show you in Finder. Does that make sense?
I'm not seeing that. I'm looking, but that's not what I'm seeing. I looked inside of terminal and did not see that. Checking now. It did indeed. You're right. Okay, awesome.
Yeah,
yep.
For sure. No, that's a great question, because you're absolutely right. We do want that code to live inside its own directory, inside its own folder. And that's just such a common thing that Git does that for us. And what is cool about Git is we have to learn kind of how Git works, but otherwise we get to work with folders, directories, and files like normal. Yeah, what else is on people's minds? What other questions do people have about this step? Did anyone run into any issues? Can people now see and edit this code in Visual Studio Code?
I do have a question. How do
Yeah.
you tell if you're working in a repository or just base files again?
How do you tell if you're working in a repository or just base files again?
Great question. There are two ways to tell. From the command line, if you type Git Status, if you're in a repository, it will give you information, like the name of the Git branch that you're on and some information about if anything has changed. If you're not in a Git repository and you type Git Status, you will get this error message, not a Git repository, blah, 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 blah. And the nice thing about that is, like, we don't have any more directories inside this algo 99 bottles directory, but if we did, we can type Git Status anywhere, and it works just fine as long as we're somewhere inside the parent folder for the whole Git repository. Did that make sense?
Yes, it did. Thank you.
For sure. The other way you can tell is if you're in the root directory of the project, and there's that term root or base directory you'll hear come up many times. What if you type on the command line ls-a to look for files and directories that start with the dot, you'll see this .git directory. And this .git directory, again, is what makes the magic happen. Like, wherever that .git directory is, that location is the base directory, the root directory of the Git repo. Like, I could go ahead and make a directory, my folder. And now if I'm in my folder, I can type Git Status and I see all the same stuff. The .git repo isn't here, but I'm inside it because my folder is inside this algo 99 bottles folder, and I could add files in here and do all sorts of stuff. If folks are feeling a little overwhelmed by all of this, that is okay. It's a lot of information. I promise what happens is, again, it's like learning to ride a bike or learning to play an instrument or woodshop class or learning a sport. Once you start doing it, that's when the concepts really start to click and you start to feel more comfortable with stuff. It's really hard to learn programming just by talking about it. You really, I think, have to do it because the concepts are so foreign and complex that you have to be able to kind of interact with something to really start to wrap your brain around it. So it's really going to be in the doing when you really learn these things. So don't worry too much about feeling like this is a lot of information. It is, and it's as we write our programs and do stuff that we'll really start to understand things. Let me go ahead and show you now how to make a change, save it in our Git repository, and send that change or push that change back up to our GitHub repo in the cloud, our main repo, the origin, so to speak, is the term. I'm going to add a very simple hello world message. And so I've got a JavaScript program here that's got a function named bottle song. When it's executed, it just prints hello world. I'll put it here below. Actually, I'll do two things. And then on line 5 here, I execute this function called bottle song. And just like we saw with our other hello world, we can use the Node.js program, Node, to interpret, to understand and execute JavaScript on our computer. 99bottles.js. And we see hello world. So here's the fun part. Git status. We're not going to worry about branches for now. Branches are basically ways to have different versions of the same file. But they do a lot more, but we're not worrying about that yet. This is the interesting part here, where it says changes not staged for commit. In Git, a file or a change to a file kind of has three states. It can be tracked or untracked, it can be staged, or it can be committed. So the committed is the one that we're kind of the most familiar with. If you commit a change in Git, Git will save that for you. It is there no matter what you do, unless you do something very specific to get rid of it, which you won't really probably do by accident. This is what's cool about Git. Anything you do inside a Git repository, inside a directory that has that .git directory in it, it's tracked by Git. And then we can save those changes. And I can do more than that. Git has a command called Diff, which is short for difference. And it gives me a whole bunch of information about the file. It shows me in red a line that I deleted with this little minus sign indicating that it was deleted. And I believe in green, it's a little hard for me to see on the screen, the line that I added with this little plus for the line that I added. VS Code also has its own kind of built-in extension for managing GitHub. I've got a lot of crap here right now. I'm not sure what all this stuff is, to be honest. We're going to dive a much deeper dive into Git and GitHub later. There are a couple tools. Yeah, I think Git graph we don't really have to worry about. This is this is a bit of a mess because this is all of I'm kind of seeing all the different Git repositories that I have in here, which is a bunch. But let's see, I wish I could just delete it. If you want to, for everyone else, for this source control extension, it will show you should just have the one repo, Algo 99 bottles, and you can kind of see some information in here. I would recommend sticking with the command line for the moment. I know the command line, especially if you're new to it, is confusing. It's stuck around since the 1970s and is still like sort of the programmer's workbench. Like it'll be around for probably another 20, 30, if not 100 years. So it's a very valuable career skill, and it's something that it will be very helpful just to get comfortable with. So with Git on the command line, the big commands honestly are Git Status, because you always are kind of checking what's going on. If you type Git Diff, it will show you all the changes that you've made that you haven't yet committed. So what we do in Git when we want to save work that we've done is what's called staging. The command is called add, git add, and the name of the file that we want to add the changes that we've made. And if I type Git status now, it says, hey, there are some changes to be committed. Git won't let me mess up this file. I could change it some more, but then I would just have to add it again. Like for instance, if I added a bunch more exclamation points and I typed Git status, I would see there are some changes to be made. And I would see there are some changes I made that are not tracked, that have not been added. So I'm going to do git add and the name of my file again. And if I do git status, I see that everything is ready to be committed. So just to kind of recap, you write some code. You want to do this in small chunks. You use the git add command to stage those changes, which means they're ready to be committed and they're locked in and you can't mess with them. And then you can commit. What I would recommend doing is on the command line, use this command -m, which is short for message, this -m flag, and just add a very short message saying what you did. The reason I recommend doing the -m is because if you just type git commit, it will open up a text-based text editor called Vim that you can write in, but Vim is kind of a strange editor. It doesn't work the normal way most editors do, and it's all text-based and not worth worrying about right now. So it's much easier just to use -m on the command line and just add a short message here.
Adam, quick question.
Yeah,
So let's say we do this every 15 or 20 minutes. So we're writing our code, we do this save. Do we do an add every 15 or 20 minutes and a commit every hour? Or do we commit every 15 minutes? What gives us the ability to move back in time 15 to 20 minutes or an hour or two or 10 hours?
yeah, that's a great question. So the short answer for now is that the programs that we're writing are small enough where you don't have to worry about how often you're committing. As your programs start to get bigger, honestly, you might want to be adding and committing like every 5 minutes or every line. Like what I've been told that I think is really good advice is every commit that you make should capture your whole program in a state where it runs and it works. And that way, if you lose some work or you have to go back in time, you are always going to go back to the point where your program is working and everything's running. And there have been a bunch of studies basically that show that the sort of more senior software engineer gets like smaller chunks of work they do. What everyone's going to discover really quickly is that programming is so complicated that the only way you can really reason about it is to like do a little bit of work, run the program, see if your code is working the way you thought, and then do a little bit of more work. What you want to avoid is like 2 hours of coding where you haven't run the program and then you run it and you have 20 errors and now you have 6 hours of debugging. You want to work in really small chunks, like write a couple lines of code, maybe even just one line, maybe even like just a change to one line, run it. Does it work? If it works, add that change and commit it and then keep moving. It's okay to have really tiny commits. And we'll get into how to kind of move back in time with Git and the command line later. It is very doable, but also requires a bit more digging into Git. So I don't want to open that door right now. I will say that right now, especially because our programs are smaller, it's not as relevant. It becomes really valuable for like around like week 8 with like bigger programs in the personal project. For people that are interested though, we can definitely dive into that. And I think everyone's going to be getting pretty comfortable with using Git. There are some interactive GUI tools that you can use as well. And if people are more comfortable with those, and we'll start sharing them, I definitely encourage people to do that. I do think it's worth giving the command line a shot, but if you feel like the command line is really slowing you down, then focus on writing the program and use a different tool. Once I've committed, if I type git status, I see that everything is clean. I have this message that my branch is ahead of origin/main by 1 commit. And we'll talk about what that means more later, but essentially origin refers to GitHub up in the cloud. Sorry, if I type git log, that gives me a history of each of my commits, and I can see the one that I just made here. There are a lot of commands we can use on the command line to get more information about this, but just as a very basic one. As you can sort of start to get the idea, like each commit, it's like each one is built on top of the last. Each one just represents a little change, but then you add them up together to get the whole picture. The last piece of the puzzle is we want to take this change that we made and send it to our GitHub repo in the cloud. And I type git
Hey, Adam,
push.
I have some questions.
Yeah, absolutely.
I'm trying to understand the git add and commit. I'm kind of
Yeah.
confused about those two.
For sure. And to be honest, I think it is kind of confusing concepts. Let me go ahead and make another change and we'll walk through it. Let's do something like just to make something a little more interesting. I'll create a variable called num bottles, which I should probably not make a const. And let's print a message so we can get a little closer to our program. And so honestly, the most important part here is now that I've made this change, I'm going to run my program again. Always, always, always run your program after every little change. It's very easy to miss a typo. And the great thing is if I have a problem here, like maybe I forgot the plus. I mean, I get a nice error message, but even if I didn't, I get a syntax error. And it's also like I've only changed one line of code. I know the problem has to be somewhere in here. So it's really to your advantage. I'll just retype it. I think something was getting funny with something else. It's really to your advantage to work in really small chunks and always be running your code. A mentor of mine said that he gets really uncomfortable if more than 10 minutes goes by and he hasn't run his program to make sure that it's working. So I've made another change. If I type git status, it tells me that this file has been modified, but it's telling me that Git is not tracking this file right now. Like if I went ahead and deleted the change that I made, there would be no way of retrieving it because it hasn't been tracked by Git. So this change is in, let's call it, it's, well, I guess we should say exactly, it's not staged. So what we have to do is, and a good example, actually, let me make another JavaScript program. And let's pretend, just for the sake of argument, that I had these two programs, or these two files rather. They're sort of separate JavaScript programs, but that's not really relevant. These two JavaScript files. And I've got, now if I type Git Status, it tells me there are two changes, a totally new file and a file that Git already knows about that's changed. Let's say I just want to deal with the totally new file. So right now, I ran git add and this new file that I just called otherprogram.js. And so now this file has been, the term is staged. Git is tracking it. Git will save it. It's like, what's a good analogy? It's like when you're waiting to get your seat at the restaurant. It's like you're in line, but you haven't sat down yet. So staging is how you tell Git what changes we want to actually commit and permanently track. So right now, this change is staged, but this one is not. So if I type Git, yes, actually, yeah, I should totally check in. Yeah.
So if we git add every 5 or 10 minutes, we have the capacity, the latitude to go back to each one of those steps in the past.
Exactly.
And then what does the commit do? So the commit then just takes all of those changes and creates some other type of breakpoint or?
Right, that's a good question. So let me go ahead. I should rephrase. When we commit something in Git, that's what tracks it permanently. And it's the commits that we can look through. If I add this other change that I have, right now I have two changes to be committed. And let me go ahead and do this. In fact, let's see, should I do it? So git add doesn't save anything permanently. And for instance, I could run this command that they tell me here, git restore -- staged. And now I'm only tracking the change I made to this 99 bottles file. And I'm not tracking this new file that I just created. And I'm going to commit that change to the 99 bottles file. And I see that I still have this other new file that's untracked. I'm going to add that. What I would say is like, yeah, when you add something, when it's staged, it's like, I almost want to say on deck, almost like, yeah.
I think I have a capable analogy. Imagine you were at a shipping office and you wanted to stage or process packages for shipping. Not all things in your company are ready to be shipped. When they are staged, they sit in a pile, and when the delivery person comes by, he only grabs the things that are in the added pile, the staged pile.
Jim, that is an awesome analogy. Thank you.
Okay.
Yeah. Like, yeah, I would say that's exactly it. Like, we want to hand off the changes that we've made from living just in our file system to Git, which is in our file system too, but kind of in a different part and tracking everything. And just like you said, like when the delivery guy comes by, he only grabs the packages that are ready to be shipped, that are staged. And so when we run this commit command, it only grabs the changes that we've added that are staged and ready to go. Is that analogy helpful for folks? A little bit? Cool.
One question though, do we have to stage before committing?
Great question.
If we say commit? Okay.
Yes. Well, let me rephrase. If I look at Git status right now, I see that nothing is staged and I have this file that's untracked. I can go ahead and commit. But there's nothing there. You can run the git commit command, but if nothing is staged, it doesn't do anything. So if you want to save a change, yes, you have to stage it and then you can commit it.
So do you add files and stage all things that have been, or excuse me, do you git add individual files and git commit grabs all added files?
Yeah, exactly. The staging and adding terminology is a little weird. Like you are kind of adding something to the staged pile of stuff. And to be honest, I should really find a better analogy. I should find a better resource that describes it better. But that's exactly it. The add command like adds something to be staged. We want to add the change that we made to this file to the list of changes that we're adding it to the staged pile. It's like trying to think. This is a weird analogy, but if you're going to like bake some cookies in the oven, you put like you've got the big bowl of dough and you pull out the dough with the cookie dough and you knead it into a cookie and you put them on the baking tin and then you put the baking tin in the oven. Well, if you imagine like the baking tin of the cookies going into the oven and then the oven like cooks them, like those cookies are committed. They're done. They're cookies now. But like if you want the cookie to get cooked, it's got to go on the baking tin. It's got to get staged. It's got to get added to the tin. It's got to be in like the ready pile, so to speak. And so it's like we make these little changes to our code. And when I've got a change that I like, that I'm ready to save, I add it and it goes in that ready pile. It's now staged. And maybe I've got 2 or 3 changes that are all related. I'm going to add them together. And in fact, I could demonstrate that right now, which is probably a good thing to do. Let's say I've got this other program. Let's say I want another console log message. Yes.
Is there a mechanism to add all files that are changed and then commit all files, or do you add files individually?
Great question. There is a message to add all changes. So right now, I have one change to be committed, which is that Git is tracking this new file. After I added that change, I changed the file again. I added another commit message. And if I do git diff other program.js, it shows me, it looks like it's got both of them there. I'm not sure why, to be honest. But to answer your question, if I do git add dot, the dot will add both of these changes. And now I have everything that was unstaged has been added and is ready to be committed. So I guess the analogy here would be like, I added another cookie on the baking tin and I added a blueberry muffin. Let me talk a little bit about the git push command quickly, just to make sure that we kind of close the loop. Has anyone ran git push after committing something? And if not, could you go ahead and maybe commit something or make a change and add it and commit it and push it? Because I think depending on what kind of authentication you're using, an extra step might come up. And if someone sees a message, please let me know when that happens. But just to kind of walk through what's happened here is I told Git, send these changes, push these changes that I've committed, send them to my GitHub repository, my Git repository in the cloud in GitHub. Because sort of by default, our Git repo in the GitHub service is the main one that's called the origin. Like in theory, we could have like 5 different Git repos on like 6 different computers on 6 different networks and send everything around. But there's still one that's sort of like the source. And if I go back to my repository here and refresh the page, so let's look at, so first of all, I've got, I should have my new file, shouldn't I? But did I not? Oh, maybe I didn't. One moment. Did I do something silly?
Yeah, it looks like you're on the Sierra Platoon.
Oh, yeah.
Yeah.
Yeah. Okay, well, we'll have to, let me quickly fix that. Let me just quickly fix the Sierra one. I apologize. And then this does show one of the tricky bits of forking. And I totally forgot about that because, to be honest, usually when I'm working like at a company, I'm like cloning from a repo and sending to it. Hold on 1 minute. There we go. Okay. Yeah, so I goofed. Essentially, when I forked and then cloned, I did not have the Git repository on my computer pointing to my Git repository on my account. I had it pointing to Sierra Platoon And when I pushed, I sent the changes to the Sierra Platoon, the I'll go 99 bottles repo on the Sierra Platoon, which was not what I wanted to do. So let me just quickly make this change, which, if nothing else, I guess is a good example that like this Git stuff, it's complicated, but it's not magic. Like you can kind of see like a URL here, and now I'm going to go ahead and change it with this command set -URL origin git at github.com Adam C / algo -99 bottles. Let's see if this works. Because the remote contains work that you do not have. Let's see if that works. There we go. Okay. So I apologize. That was a bit of a digression into stuff that we don't need to look at too much right now. And so there may be a step with the forking and the cloning where you need to tell Git to talk to your GitHub repository and not Sierra Platoon. And I kind of jumped over that step. But now that I fixed that, what we can see is that the changes that I've made are here, and that we can kind of see and walk through the changes to these files. Like here is my first hello world change. So this is one commit. Here is another commit where I changed the 99 bottles file and added this. And you can see what changed in the file and my commit message. And then here on this most recent one, I changed 2 files, but that's still captured in one commit. And we'll see kind of later how to do this. But what this lets me do is now I have like 3 points in time in my code base that I can move through. And also now if I do something that I don't like if I accidentally delete all this stuff, and if I accidentally delete this other program file that I made, and there's this stuff that I don't like, I don't have to add these changes. I don't like these changes. I can use Git Restore to get those changes back. So I've got one file that I've deleted and another that I've changed, and I ran my code and I was like, oops, this isn't what I want. So I could do Git Restore other program.js. And now that wipes away those changes and it grabs the most recent commit, and that file is back to a good place. And I can do Git Restore 99 bottles.js. And
How
now,
do you know?
Yeah.
How have you communicated which version you want to restore to?
Yeah, that's a great question. So what Git does, and this is kind of where the term branch comes from, like each commit is in order, right? Like this is the first commit, this is the second commit, this is the third commit, this is the most recent commit. Git calls the most recent commit the head of the branch because it's at the front of it, it's at the head. If I make a bunch of changes to my code and I haven't committed those changes, what Git is doing is comparing the current state of what's called the working directory, these files, with the most recent tracked commit in Git. So it's always going to look at the head of the branch, the most recent change, but it kind of looks at, it doesn't just look at this one little bit. What it does is it adds up all those changes to get the full picture. So right now, Git is comparing the current state of this working directory with this code against the committed version of that code, if that makes sense. There are a lot of ways where you can, like, if maybe you're like, hey, I screwed up here. I actually want to go back in time to this other commit, and this is the one I want to use moving forward. There are ways to do that too, but we'll get into that more later. Did that help a little bit, Jim?
Yes, thank you.
For sure. For sure. I know this is a lot of stuff. And in a lot of ways, half the value of Git and GitHub is if I need to, for some reason, I can go to GitHub, and I'll use GitHub a lot of the time instead of Git if I want to like explore my code, to go back in time and search for stuff. Like if you are working on a program and you make a bunch of commits and then you realize you need to go back in time, right now I would say, unless you want to kind of figure it out yourself, message a TA or one of us. Also, to be honest, you could always just look on GitHub and look at the commit history and do a bit of copying and pasting. You know, it's sort of a manual, less clever way to do it, but it's there. So I'm going to go ahead and do Git. You can also do Git checkout, which will grab whatever the most recent version of those of the branches. And I'm not sure I want to get into the difference between like Git Restore and Git Checkout right now, but they essentially do the same thing. Like checkout is going to, these changes are not staged. This is like, it's like if I took cookie dough out of the bowl and I formed it into a cookie, but it's just in my hands. I haven't put it on the tray. If I do Git Checkout, I'm throwing that cookie dough back into the bowl with all the other dough. Oh, I thought, let's try Git Checkout. There we go. Yeah, I apologize. You with Git Checkout, you do need to specify the file that you want to check out. And if you use that will check out all the files. So now I threw the cookie dough back into the bowl. So there are a lot of different ways to do stuff with Git. We're gonna dig in deeper. I think for now, the key steps are forking that repo, cloning it, and starting to get comfortable with writing code, adding changes, committing changes, and then pushing changes back to your repository on your account on GitHub. And then if I want to share this code with someone else, I can just share the whole repo link, or I can click on a file and share a file. I could even click on like a line number here if I want to share it in Slack with someone. And you can just share that link as long as the other person has access to that repo. I guess it's private by default because our homework one was private. I honestly would recommend making most of your repos public for people to see. There's no reason not to.
Adam, a quick question.
Yes.
I saw that you showed the dot method for Git add to add to stage multiple files. for commit also, we can use the dot also, right?
That is a really good question. We don't need to use the dot for commits because when we commit, it only commits what we have already added and staged.
Okay, guys.
So,
Yeah,
see-
it makes sense.
Yeah, that's a great question though. But you're correct that that dot syntax is pretty common. It might come from regex. I don't remember, but you'll see essentially the dot means everything. Should actually see where does Git dot. See, the dot stands for the current directory. Okay, that makes sense. So in terms of the command line and navigating, I need to do a little reading to explain this properly, but with the change directory command, I briefly showed that 2 dots will move you back. If you do cd space dot, it just keeps you where you are. The dot symbol represents the current directory and 2 dots represents the previous directory. Just as a fun fact, if you do cd space dash, it takes you back to where you last were. But so when I do git add dot, what I'm saying is git add everything in the current directory, which I actually did not know. So yes, thank you for asking that question. I didn't know where that came from.
I got a quick question, sorry.
Yeah, no, it's awesome, please.
So when you're saying that this Git, when we fork it, it's private, would it just be wise to make our own so that when we're doing all this, because I keep running into I don't have access to this when I'm trying to do the push. Since I forked it, am I messing something up, or do I just need to make my own repository in my file so that I can just keep messing with it directly and not worry about the private?
Yeah, I may have skipped a step that we need to do on the forking. I need to see. If you actually don't mind sharing your screen, we can do a bit of group debugging, and then that actually might be a good, after that, a good breakpoint.
Okay. So
And this is good because Jaden, there's like a 75% chance that a couple other people have the same issue.
can you guys see that? Oh, I have to share. I have to commit. Okay. Can you guys see that?
Yes, I think you just will want to make the terminal bigger to take up the screen, and you might have to hit like Command plus a couple
30 feet
times.
probably.
Yeah, can you hit Command plus a couple times to increase the font size?
Yeah.
Perfect. Or here, I'll let you get it sorted out.
Yeah. Sorry, I've
No worries at all.
not used
Thank
to
you
this
for being willing to be
Mac.
on the spot. I know it's a brave new world.
All right, so this is what I was doing, and can you guys see that, or is my screen?
Can you maybe do Command plus once?
It's probably because I have a really
Oh God. Okay, I apologize. Yeah, we'll work with it. We'll work with it. I'll kind of talk through it too. I'll throw it on a bigger monitor here, and then I can
here. I'll do
see it.
this.
Oh, that's perfect. That's great, man. Whatever you just did, that's perfect. Thank
I
you.
just switched my monitors. I didn't think that was going to be an issue, but
Cool.
all right. So, okay. So this is kind of where I was running into the issues when I'm trying to push it. Just saying I don't have.
Right. Okay. Do me a favor. Type PWD really quick and hit enter. Okay, so you're in the right directory. Will you do Git Status for me really quick? Okay, Awesome. So you've got, so you might have to commit those changes, but we'll worry about that later. But you're in a Git repo. Go ahead and do Git remote for me, and let's see if, yeah, and just hit enter. Or I think it's remote space -v. I apologize. I think the V stands for verbose, but I'm not sure.
Capital or lowercase, doesn't matter.
Lowercase. Good question. Yeah. Okay. So what this says is that it is pointing to your GitHub account, which is great. I wasn't sure about that. Let's try. Yeah. Try Git's push. Try, instead of -f, try origin.
Doesn't he have to commit first?
He should commit. I mean, we can push without committing. But you're right, that couldn't hurt. So let's actually go ahead and commit those changes. So right now those changes are staged, but they're not committed yet.
Oh, is that the stage I probably forgot here? And do I have to type in the grandma here, or once I hit git commit, or is it gonna already know to do both of these?
Right now, it knows that both of those are staged, so it will commit both of them. I would just add the -m flag and a short little message. Otherwise, the Vim text editor will pop up and it's got its own weird little
Like that?
ways of doing things that can be confusing. Yeah, I would just throw like a, you don't just, yeah, exactly. That's perfect. Okay, and now if you type git status, it should say like everything
this
is fine.
the stage this is probably what I messed up on here.
Well, I'm not sure. But so this is good. Now let's try git push. And so Jim was totally correct. Those changes were staged but not committed.
Okay.
But we
that
might
makes-
run into the same authentication issue. Let's just try git push and see what happens.
There we go.
Oh, okay. I eat my words. It looks
missed that step.
like that works. Yeah,
Okay.
Jim, thank you.
Perfect. I was like my head against the wall. I was like, why is I like, because I thought I hit commit, but I guess I just I staged them. I didn't do that next day committing to
Yeah.
okay, cool.
Exactly. And that's okay. The one piece of advice I have is I'm typing git status all the time after like literally every single command I do in Git, because Git is a powerful tool and it is also complex. So that is okay. And it's okay to take your time with it. I think you're good to go, man. If you go to your GitHub, those changes should be up there now, and then you could share that link with me or Zainab or the TAs and we could look at your code.
Okay. Well, that it's not done. I just was trying to figure
For
that
sure.
out, so
Gotcha. No, this is great, man. Thank you. And you're still sharing your screen, FYI.
sure. Thank you.
For sure. Yeah, and hopefully that was good for other people to see too. Just to reiterate, like there's a whole range of like experience levels with tech stuff that we're bringing to the table here. So I think it's going to be cool because everyone's going to be able to help each other out. And so right now, if anyone's kind of feeling overwhelmed, you're like, this is a lot, that is okay. And you're not alone. And if anyone's like fiending for more, we can definitely help you out. We've got our stand down in about 20 minutes. So let me stop. Well, actually, before I stop recording, are there any other questions that people have? And then maybe I'll stop recording and we'll ask more questions.
Yes, so I got a question. Once we've done, these two assignments, you said we're going to send a link. Where are we sending that link to?
Yeah. Truth be told, you don't have to send the link anywhere. With the amount of people we have in the class, it's hard for us to do like a full code review of everyone. So the assignments are really more for your own benefit. What we do try to do is in the mornings or at the end of the day, we will ask for volunteers who maybe want to share their code and walk through the assignment, or sometimes Zainab or I or us together will like write up our own code so you can see like how we would tackle it. What I would say is if at any point you want a set of eyes on your code for like a code review or feedback on what was good, what you could improve for a programming assignment, just hit us up in Slack. Hit us up or one of the TAs, but we don't have any sort of like formal mechanism for that.